we're going to go ahead and look at section 7.5, which is operations with radical expressions. This note sheet is a little bit long, so we're going to go ahead and break it into two videos. So the first one, we're going to look at the properties of radicals. Biggest thing to remember is that for any real numbers a and b, and any integer n greater than 1, the following properties hold true. Okay, so the first one's the product property. If I have the nth root of a times b, I can break that up as the nth root of a times the nth root of b. Notice, if I was given something like this, I could work my way back. So it goes both ways because it is an equal sign. Okay, so if I have the square root of 2 times the square root of 8, I really have something that looks like the right-hand side of my property, so I'm going to work to the left-hand side. So really, I can take 2 times 8, and I would get the square root of 16, which is 4. Another example, if I have the cubed root of 3 times the cubed root of 9, I can rewrite that. The cubed root of, 3 times 9 is 27. Well, the cubed root of 27 is 3. Our next one is our quotient property. Okay, if I have the nth root of a divided by b, I can break it up as the nth root of a divided by the nth root of b. Biggest thing, though, is that b cannot be 0, because if I have a 0 in my denominator, it is undefined. Okay, so let's look at another example. So if I have the cubed root of 54 over the cubed root of 2, I can rewrite that as the cubed root of 54 over 2. 54 divided by 2 is 27, so I have the cubed root of 27, which is 3. Okay. So those are my product and quotient rule. Remember, when simplifying a radical, no radical in the bottom. Okay, you can't leave a radical in the bottom of a fraction. So, the first one is just showing that if I have just y, this is fine because there's no radical here, and then there's no fractions underneath a radical. So, never want to have a fraction, okay, so you can't have, they don't ever want this, something like that, or they don't ever want a radical in the denominator. Can't have that down there. So they want you to rationalize the denominator. Okay. So to rationalize the denominator, multiply the numerator and denominator by a quantity so that number underneath the radical is an exact root. Okay. So you guys have a little bit of a fill in the blank. So it says to eliminate radicals from a, should be denominator, you must rationalize the denominator. Okay. To do this, multiply the numerator and denominator by a quantity so the number underneath the radical is an exact root. Okay, so there you go. So let's look at the example you have on your note sheet, the square root of 9 over 5. So this would break down to square root of 9 over square root of 5. Well, I cannot have, okay, a radical in the denominator. So what you do is you would multiply by the square root of 5. If it's a square root, because I know 5 times 5 will give me the square root of 25. And then whatever you do to the denominator, you need to do to the numerator, okay? Because the square root of 5 over the square root of 5 will simplify to 1. You can multiply anything by 1, okay? So I would maybe, before we continue, I'd break this down. The square root of 9 is 3. So I would have 3 square root of 5 over, well, this is square root of 5 times square root of 5 is square root of 25. So this would be 3 square root of 5 over 5. And I have rationalized the denominator here. Okay. My next example that you guys have on your notes is the cubed root of 3 over 9. Okay. Well, let's go ahead and break it up like we did before. We have the cubed root of 2 over the cubed root of 9. Well, I cannot have the cubed root of 9 in my denominator because there's a radical there. So in this case, I can't just take it times the same cubed root. I have to think, well, what do I know the cubed root of? Well, 9 times 3 would give me 27, and the cubed root of 27 is 3. So what I would do is I would multiply by the cubed root of 3 on the numerator and the denominator. Okay, when I do that, if I combine what I have here, I would have the cubed root of 6 all over the cubed root of 27. Cubed root of 6, I'm going to leave as cubed root of 6. Cannot take any piece out of there, and the cubed root of 27 is 3. I do not have a radical in the denominator, so there my denominator is rationalized. Okay? So let's look at some examples. 1, we need to simplify. So I need to think, well, this is a square root. Is there any perfect squares in there? And I would see that 9 might take a little using on my calculator to figure it out. But 9 times 22 will give me 198. Okay, so I would say, well, what's the square root of 9? 3. Square root of 22. Okay, is there any perfect squares left there? No, there is not. Okay, that's one way you can think about it. Another way is you maybe like to go ahead and break it down. You might see that 9 times 22 is 198, and then you like to break it down even further. This is 3 times 3, and this is 2 times 11. Okay, so now I have it broken down into primes. Maybe you've seen it done this way. So I'm just going to rewrite it. I would have 2 times 3 times 3 times 11, really underneath my radical. And if it's a square root, if there is a pair, you can bring it out, because really that's 9. Okay, so it's 3 times, well, 2 times 11 is left, square root of 22. Okay, so that's another way you can go ahead and think about it, if you like to break it all the way down into all the factors. Okay. Example 2. We have 3 times the square root of 54. Okay. Well, I know, and you should know, that 54 is 9 times 6. And 9 is a perfect square, so I would have 3 times, well, the square root of 9. Square root of 9 times the square root of 6. So I'd have 3 times square root of 6, so it's 9 square root of 6. There it is, simplified. All right, example 3. We have the square root of 128, x to the 4th, y to the 3rd. So, try and think, what perfect squares would be in 128? 64. So, 2 times 64, x to the 4th. Now remember, this is a square root. Okay, so when it's a square root, you can only divide by 1/2. 3 is not divisible by 1/2, so I'm going to rewrite it as y squared times y. Okay, so I would break it down. Square root of 64 is 8. The square root of x to the 4th, divide 4 by 2 gives you x squared. Square root of y squared, 2 divided by 2 will give you 1. And then whatever is left underneath my square root sign, 2y. There it is, simplified all the way. Example 4. We have these two. I'm going to go ahead and multiply what we have together. Okay, so 24 times 12 is 288. X to the 6th times x to the 1st, well, you add those exponents, so I have x to the 7th. Then I have y to the 3rd times y to the 1st, so that gives me y to the 4th. So now I break it down again. I would think, what perfect square is in there? 2 times 144. Okay, and maybe if you need to, maybe I should have wrote this down earlier. If you need to, I would write out a list of the perfect squares. 1 squared is 1, 2 squared is 4, 16, 5 squared is 25, and keep going. Okay, 36, 49, 64, all the way up. Okay, so I'd have 2 times 144, then I would have x to the, well, it's 7, so I'm going to rewrite it as x to the 6 times x, and y to the 4th. Now breaking it down. The square root of 144 is 12. The square root of x to the 6, 6 divided by 2 is x to the 3rd. Y to the 4th, so 4 divided by 2 gives me y squared. And then whatever I have left is underneath my square root sign, so it's the square root of 2x. There it is, simplified all the way. Okay. Example 5, we got some division. So I'm going to go ahead and break it up. So I would have the square root of 18x to the 4th all over the square root of 7y squared. Before we rationalize the denominator, let's go ahead and simplify. Okay, any perfect square is in 18. 2 times 9, 9 is a perfect square. All over, and I'm just going to simplify this. 7 is not a perfect square, but the square root of y squared would be y square root of 7. Okay, so now I'm going to rewrite the numerator. So I would have 3x squared square root of 2 all over y square root of 7. Okay? Now remember, I cannot have any radicals in my denominator. Okay? This y is fine. It's not in a radical, so that can be there, but I cannot have any radicals. So I would have to say, well, what's going to be a perfect square? What do I have to multiply 7 by? Well, 7 times 7 will give me 49. So I would multiply the numerator and denominator by the square root of 7. So if I simplify, I would have 3x squared. 2 times 7 is 14, so square root of 14 all over. Okay. Well, I would have y, and then I would have 7 times 7, which is 49. Square root of 49 is 7. And I would double check any perfect squares in 14. The only thing that multiplies to 14 is 1 and 14 and 2 and 7. So we are simplified all the way. All right, we got another one. Breaking it apart, numerator and denominator. Okay, well, I would say square root of 5. No perfect squares in that. Square root of 4, though, is 2. Just have the square root of a. So in order to get this one, I would have to multiply both by the square root of a. Well, underneath my radical in the numerator, I would have 5 times a. No perfect squares there. A times a would be a squared. The square root of a squared would be a. So I have 2a in the denominator. Okay. There is 6. Let's go ahead and look at 7. I have m to the 9th. So I have the square root of m to the 9th all over the square root of n to the 7th. So I'm just going to simplify this one first. I'm going to break it down to this is square root. So m to the 8th times n over n to the 6th times n. This will give me m to the 8th. The square root of m to the 8th will give me m to the 4th, square root of m, all over n to the 3rd, square root of n. Now, once again, I need to rationalize my denominator, so I would multiply by the square root of n. So I'm left within my numerator, m to the 4th square root of m times n, all over, it'd be n to the 3rd times, well, the square root of n times the square root of n would give me just n. So I have n to the 3rd times n. So I should rewrite that one more time. So I would have n to the 4th square root of m n in the numerator, and n to the 3rd times n to the 1st gives me n to the 4th. And there it is, simplified all the way. Okay, if you're getting to that point where you need to do less steps than me, that is perfectly fine. You don't have to write down. I'm just trying to write down as many steps to help you out as possible. Okay. The next one, we would break up. We would have the 4th root of x to the 3rd over the 4th root of 2. Okay. So in this case, I would go ahead and think, well, the 4th root. Well, what number would I have to have in order to get the 4th root? The smallest one I can think of would be 2 times 2 times 2 times 2, which is 16. So 2 times what would give me 16? Well, 8. So I'd multiply by the 4th root of 8 on the numerator and the denominator. Okay. So I would have the 4th root of 3 times 8 is 24x, all over the 4th root of 2 times 8, which is 16. If you check the 4th root on your calculator, 4th root of 16, you will get that it is 2. So you have the 4th root of 24x all over 2. And there, that one is simplified all the way. Okay, we're going to do 9 and 10, and then we're going to call it a break for the day. So make sure if you have questions, you're writing them down so that I can help you if we need to. Okay. So number 9, I look at this. There's numbers out in front of my radical, so I'm going to multiply them right away. 5 times 4 is 20. Then I will have the 4th root of, let's just multiply everything right away. 24 times 54 gives me 1,296. X to the 3rd times x will give me x to the 4th. Okay. And actually, if you try on your calculator the 4th root of 1,296, it will tell you that it's 6. It is 6. So it's 20 times the 4th root of this is 6. And what's the 4th root of x to the 4th? Well, since it's the 4th root, it's really x to the 4th to the 1/4 power. Just maybe write that out. Since it's the 4th root, 1/4. So 4 times 1/4 is just 1, so it's just x. So I take 20 times 6, which gives me 120x. And the last one for this video, Similar to the one we just did, multiply those terms out in front of your radical. So I would have 7 times 3, so I would have 21. Then I would have the cubed root of 75 times 45 gives you 3,375 a to the 6, because I would add 4 plus 2. And now on your calculator, if you try the cubed root of 3,375, I would really like for you to try that. You should see that it is a value. It should tell you that it's 15. Okay, and then a to the 6th. So it's really 6 divided by 3, which gives me a squared. So I just have to take 21 times 15, which gives me 315 a squared. Okay, we're going to go ahead and stop the video here for today. So make sure if you have any questions, look it over. It's a lot to take in. Otherwise, I will see you later, and have a nice day.